Looks like it's 12:30. So we'll go ahead and get started. I am Kenny Voss, the Assistant State Design Engineer. It's my pleasure to welcome you to today's webinar on erosion and sediment control and project development. This is the first webinar in our design webinar series. We plan on hosting webinars on technical training related to program delivery. Our goal of these webinars is to ensure employees receive the technical training necessary to successfully deliver projects into the future. I have a few housekeeping items to go over before we get started. We are scheduled for 2 hours today. This includes time for the presentation and time for questions and answers. We are recording today's webinar and will place the recording in Mo.U for future reference. This webinar will also be added to the course catalog of the Program Delivery Training Program. For this webinar, all lines are muted during the presentation. The question and answer function will be open, so I encourage you to place your questions in the chat pod. We will be monitoring these questions during the presentation to determine if we should break into the presentation for clarification. We will break after the presentation and address questions from the chat, our question and answer pod. The presenters will also take additional questions at this time. So for today's webinar, I'm pleased to introduce our speakers. Brian Williams is the Storm Water Compliance Coordinator in the Design Division. Brian is responsible for MoDOT's land disturbance and TS4 permits and the stormwater database. His primary responsibility is education and quality assurance of these programs. Willie Johnson is assisting with questions during the presentation. He is a field materials engineer in the construction division. Willie works with our construction inspection staff to ensure quality control of our stormwater program. These two gentlemen work closely together to ensure we have a successful stormwater program at MoDOT. At this time, I will hand it over to Brian for his presentation. Take it away, Brian.
Thank you, Kenny. I want to welcome everybody today to Erosion and Sediment Control and Project Development. How to design erosion sediment control plans from a designer's perspective. Today we're going to talk through the process of thinking about erosion sediment control. We're going to talk about why erosion sediment control is important, look at permit compliance, some EPG guidance, frequently used BMPs, talk about a little bit of project detail, and then go through some project examples. We'll talk about some other considerations, and then we'll open it up to Q&A. So why is erosion sediment control important? And typically from the engineering perspective, we can talk about why law, it's federal law with the Clean Water Act, Missouri Clean Water Law. But really, it really comes down to environmental stewardship. It's critical for the overall health and well-being of human life. Water is one of those things that we don't make new water. I have said that in many training, that we're using the same water that the Egyptians used. That was one of the quotes that I read at one time. And so protecting our most vital resource helps conserve the overall balance in human ecosystem by protecting aquatic habitats and food chains, as well as ensuring a viable source of water exists for consumption, recreation, and personal activities. If we don't take care of what water we have today, we won't have any for tomorrow. So it's more than just it's law. It's got to hit you in home, in the heart, basically, of why we need to do more than what we do for erosion sediment control. And it's critical that we make that step forward as we go. So we're going to talk, we'll talk a little bit about the permit and the permit compliance. So like I said before, obviously we're looking from the federal perspective. We have the Clean Water Act. And in Missouri, Department of Natural Resources is our regulating agency in Missouri. We have a Missouri Clean Water Law. Now, it's public expectation that we are good stewards of the environment, that we take care of all of our resources, but definitely from the water perspective, making sure as engineers that we're out deploying EMPs to make sure that we're not polluting our waters. Okay, and with that we have a land disturbance permit, and here at MoDOT we have a stack permit with our transportation separate storm sewer system permit and our land disturbance permit. All those are under one permit, MO 0137910. We've actually got websites out there available that you can look at from the land disturbance perspective and the stormwater perspective. So encourage everybody out there, if you've not went out and looked at our land disturbance our page or our stormwater page, go out and take a look at those on MoDOT's webpage at www.modot.org/LD for land disturbance or /stormwater for the stormwater page. Now, what projects apply when we're talking about land disturbance? Basically, all projects that are 1 acre or greater, or projects that are less than 1 acre if they're part of a common plan. We'll get into that common plan concept here in a second. But then this is a new concept with our new permit. We came up with a new land disturbance permit back in November of 2019. As we came out of consent decree in 2018, it was time, we were actually out of compliance with our permit in May of 2017, and DNR was gracious enough to extend our permit until the end of consent decree. But once we got that new permit in 2019, it actually had a lot more requirements related to common plans and how things were working together in conjunction with the federal permit. So we're going to talk about some of those, and we'll go through the permit requirements. Now, the permit obligations are really simple, and for design, these are things that you guys really need to take note of, and that is what we're really doing with this permit and what we're obligated through our plans is we're looking at being able to control stormwater volume and velocity, protect the project outfalls, keeping sedimentation on our job. Okay, everybody used to think keeping sediment on our job was the only thing we had to do. And as you can see, that's actually number 3 on the list. Okay, so understanding what these obligations are is critical from a design perspective to be able to put together a set of plans that meets the permit requirements and functions out in the field. Okay. Additionally, we're looking at protecting surface waters and directing waters to vegetated areas. Okay, those are just there's actually 7 requirements, but those are the ones that primarily focus at what design is basically functioning to take care of for us with a set of plans. Okay, the others are really pointed more toward the construction division and their operations as the contract's going forward. Okay, so let's move and talk about the common plan concept. The overall common plan concept used to really not apply to MoDOT or any state agency for that matter. In the global perspective, common plans would be those things where there was an overall plan to complete something and you put it together in pieces. The federal government used to say that the common plan concept, and then they still say, does not apply to state DOTs and their STIP work. But what DNR put together for MoDOT as we went to this new permit, because of how we have to deal with borrow sites, waste disposal sites, those types of things, they reintroduced the common plan concept so that it fits more with how MoDOT does work. Okay, for projects less than 1 acre with off-site support activities, and those support activities being those concrete or asphalt plants, locations, those borrow sites, waste disposal sites, equipment areas, any of those support activities that are off MoDOT right-of-way, they're in the control of the contractor, all have to be considered when we're looking at whether a project has to go under permit obligation or not. So if we have any of those that basically fall in that common plan concept, if we have an off-site support activity such as a borrow site, we're looking at our project and it's less than 1 acre, but in combination with those support activities, if it throws it over 1 acre, then we have to go under permit obligation, do inspections, and all the requirements the permit requires. So from the design perspective, we have to start thinking about that early. Not just, we don't have to know how big the contractor's borrow site's going to be, or if their waste disposal site, they need waste disposal sites or anything like that. But we should be able to know, based on what the application of our project is, if there is that potential that we're going to go over an acre. So if we know we're raising grade, we're asking the contractor to bring an embankment in place, then that's pretty much going to be a slam dunk. It's going to be a permit project. We're going to need WPCMs. We're going to need make sure that we've got a full set of erosion control plans, all of that. So understand what the requirements are of the permit and how that is affected by the design process. So let's switch gears just a little bit and we'll talk about changes to the EPG. And when I came out in early January, we talked about the training that we did back then. We talked a little bit about the EPG changes. After the consent decree, we talked about reconfiguration of section 806. 806 used to be one big article. And we took the opportunity after that consent decree, we rolled out and we broke up section 806 into smaller sections. 806.1 through 806.8. Obviously 806.8 is our statewide SWIP, but we looked at breaking up the article into subsections that would be more beneficial to the department. So we're going to talk about the subsections of 806, talk about 806.8. We're going to take a look at 237.2 title sheet section, where we came up with the estimated disturbed acres on the title page, and then we're going to talk about 237.4, the plan and profile sheet section. We didn't have anything in the EPG prior to the amendments to this section that even talked about erosion sediment control. I think there was maybe one sentence in that section that even glanced over erosion sediment control plans. So hopefully what we put in there is beneficial for you all, and it gives you something to go back to and reference about the permit requirements. So we'll dive right in here. So EPG Article 806.1 and 806.2. And I know what you see on the screen isn't very legible, but it's really the intent. I just want you guys to see that we have these options out there. We broke the articles up. We provided a design perspective related to 806.1 being erosion control BMPs, 806.2 being sediment control BMPs. And then for each BMP in that section, there's a design consideration and a construction consideration. And as we talk through the BMPs here in just a little bit, I actually utilized the design considerations on those slides. So you'll be able to see what some of those say and see what benefit they'll provide you as you're considering what type of project you have and what BMPs maybe you might want to consider. So 806.8, still the stormwater pollution prevention plan, our statewide plan on how we're going to comply with the Department of Natural Resources permit and how we're going to protect waters of the state. It identifies BMPs that we'll use on projects and provides some direction on contractors on what BMPs and how those function and things that we need for them to do. Okay. It is probably the only article in the EPG that we utilize as a more closely to the contract document, because the spec book does require that the contractor follows all state and federal laws, and the main disturbance permit does require that we have a SWIP. So this is where we house that. We make it available to the contractors. So if you haven't read it, I encourage you to go out and take a look at it. We made some pretty substantial changes with the new permit in 2019. It's not that we really added any information. We moved some information around, moved it out into the other subsections of 806. And I think it makes it more of a pure regulatory document as it was intended to be. But I encourage you to go out and take a look at it, read through it. If you ever have any questions, you can give me a call. You can give Willie Johnson a call. And we're happy to discuss those with you. So 237.4, plan and profile sheets. So we added a section in 237 that basically talked about what the obligations of the permit were and basically give designers something to hold on to when it comes to designing erosion sediment control plans. What are we trying to accomplish when we're out doing that operation? You know, unfortunately, erosion sediment control plans, I know as a designer, it's the last document that you put together before you submit it to central office. You spend about 2 days putting it together if you're lucky, and you slide it in a set of plans. Hopefully after today, you'll have a different perspective of what's required to put those erosion sediment control plans together. You'll spend a little more time thinking about how we put those together, what BMPs we're using, and where we're placing them. Okay, but 237.4.12 goes through what the permit obligations are. This ones I read just a few minutes ago: to control stormwater volume and velocity, to keep the sediment on your job site, to protect the outfalls, those types of items. Encourage you guys to go back and use that as a reference. Okay, the whole concept of BMPs being in place where water is going to leave the site. Okay, permit requires that any water that leaves our site passes through a suitable sediment impoundment. That reference is in this section of the EPG. So I encourage you to go out and take a look at that. It's good information. It's a good place, good reference point. Section 237.2, title sheet section. When we went with the new permit and that obligation of having a potential for common plan concepts, I wanted a way to be able to alert contractors of how large our projects were during the bidding process, so that we didn't have a scenario where a contractor didn't go get a permit and they tried to basically lay it back on us and say they had no idea how big the project was. So having that information out in front of the contractor prior to bidding can allow them to put the cost of the permits in the bid. Now, the cost to the contract for a permit is pretty small. I mean, we're talking for a permit that is 1 to 5 acres is $300. They're not a big cost, but the major cost to the contractor is they're responsible for the SWIP on those projects or on those locations, on those support activities. So adding the BMPs, being able to do the inspections on those sites, all of the same stuff that we do on MoDOT right of way, they have to do on those support activity locations. So that is a cost that is real to MoDOT. And so I wanted to be able to get that out in front of the contractor, out in the bid, so that they weren't coming back to the REs and saying, hey, we didn't account for this in our bid. So hopefully this estimated disturbed acres on the title sheet helps the contractors know, or at least have a good idea of whether they're going to need permits or not. Okay. I know some people weren't really excited about putting that on the title sheet, but again, this is just an estimate. This is something that gives the contractor an idea of, hey, am I going to need a permit or am I not going to need a permit? So let's talk about some frequently used BMPs. Typically, rock ditch checks are our most used BMP, and they are our preferred ditch check. You can see our design consideration for rock ditch checks are the predominant ditch check to be used. Because of their size, rock ditch checks are to be placed outside of the clear zone. Obviously, anything inside the clear zone that has an 18-inch effective height can cause vehicles to launch if the errant vehicle leaves the roadway. So we want to make sure that we keep rock ditch checks outside the clear zone. And they're specified for large drainage areas and ditches with slopes 10% or less. Okay. If you look at our standards, our standard plan, and you'll see the standard plan here in just a second, they top out at 10% ditch grades. So anything above a 10% ditch grade, we really need to take a look at and probably make some different considerations when it comes to erosion sediment control. So if you run into those, give me a call and we can talk through those scenarios and situations and see what we can do. But definitely limits on 10% of grade or less on those rock ditch checks as a standard. So rock ditch checks are paid by the linear foot and they're measured along the top of the ditch check. So from the design perspective, it's critical to take a look at how the standard plan lays out what's intended for a width so that we're actually paying for the right amount of ditch check. That's probably one of the biggest considerations I hear from construction and contractors when I'm out talking to them is, the ditch checks aren't long enough. Okay, so as you can see by looking at the standard plan on your right, that the rock ditch check basically should be full ditch width height, okay, and then with an 18-inch depression over the middle of the ditch. So a lot of times they get a little short, or sometimes our ditches aren't standard. So we have to make sure that we provide enough length in our ditch checks to make sure that we're protected as the contractors are putting them out there. Well, I understand we can only design it. Construction has to make sure they put it out there appropriately. And I have those conversations with them, but we need to focus on making sure that we design with enough width. They have plenty of rock ditch check to put out there. Okay. When you look at the standard, the minimum length at the bottom of the ditch plus the back slopes plus the end slopes. I mean, I put a mathematical calculation in there. It's really that simple. We don't always have standard 2-foot ditches depths anymore. So it's going to take a little bit of consideration on the designer's part to look at what our ditches are, how wide those ditch checks really need to be to make sure that we have sufficient width. We're not allowing water to get around them. So you're planning for toe-to-top installation on these. There is a spacing chart, and it's example spacing chart in 80610 of the standard plans. It's a good rule of thumb. Sometimes you have to use good engineering judgment. And honestly, I would recommend from the design perspective that we design by standard and then let construction determine if they want to use less. Okay, because the new permit, we used to have the 2.5 milliliters per liter settlable solid limit. Well, that doesn't exist anymore in this permit. So basically, we're under the consideration of the water quality criteria. Basically, is water free from oil scum, unsightly turbidity that is harmful to human and aquatic life. That is the water quality criteria from the Missouri Clean Water Law. The intent of the permit is that we are able to capture a 2-year 24-hour storm event with our BMPs. So if we put minimal BMPs out there in the design concept, and then construction has the philosophy that they think that we've designed it to meet the requirements, and they want to take a few more out of there, we're putting ourselves out there for liability. So I encourage design to standard. If it looks like too many, I'd rather have too many in there than not enough. And in that way, we have done our part as design to provide a project that has BMPs that can capture that 2-year 24-hour storm event volume. We'll talk a little bit more about that 2-year 24-hour storm event volume through the presentation. Okay. Always think about as you're determining how many of those ditch checks you need. Are you controlling stormwater volume and velocity? If you look at what you put out there and you don't think you're doing that, then reconsider adding some additional BMPs to that list. Okay. Alternate ditch checks are 9-inch effective height ditch checks. And they're not limited to just wattles and socks, triangular silt dikes, filter socks, anything but straw. Straw wattles are not approved. Anything straw is not approved in through our SWIP. So they can use sandbags. Again, they have that 9-inch effective height. and you can use them inside the clear zone. So those projects where you've got a clear zone, your ditches are close to the side of the road, they're the preferred ditch check in those scenarios. Okay. So we see a lot of ditch checks in locations where, where alternate ditch checks are used when maybe we ought to be probably considering some rock ditch checks. So make sure that as a designer, you know your route, you know what clear zone you have, and make sure you're communicating that with construction. So if there's a potential where we've got some alternate ditch checks in the project and they can put rock ditch checks out there, let them know that. Otherwise, the contract calls for them. That's what the contractor's going to do. Okay. Again, alternate ditch checks are also paid by the linear foot. The length should extend up the slope to the natural ground line. Okay. Don't cut these things short. Make sure that we provide plenty of length so we can get it across the ditch up to the natural ground line. We have a lot of trouble with water working their way around these alternate ditch checks, because whether it be because what we design isn't sufficient length, or contractors are trying to cut the corner on that. Either way, make sure from the design perspective, we're providing sufficient length to get to natural ground line. Sediment traps. Sediment traps should be used on every job. And I still, I know that the sediment traps came into our standards back in 2009. And that it's because the permit required at that time that water that passes through a sediment, passes through a suitable sediment impoundment, it was a sediment basin or sediment trap. And that's why they came into our standards at that time. John Howland was one of the ones that was involved in adding that to our standards. And in 2020, we're still having trouble getting these things added to projects. Every project should have a sediment trap at the outfall. Okay? An outfall basically is where water is leaving our site and hitting the waters of the state. They should be at every outfall. Okay, so there shouldn't ever be a question, where do we need a sediment trap and where we don't? Okay, every outfall should have a sediment trap. The length and height of a sediment trap depends on the volume of water that flows through the drainage structure and the width of the drainage channel. Sediment traps will be utilized at every outfall and may be used downgrades of drainage structures to control sediment. Sediment traps are not appropriate where impounding sediment and gravel can accumulate inside of a culvert. We should really never be putting sediment traps into the waters of the state. Well, anytime we have our ditches meet a stream or a creek, we should not be putting any types of BMPs in those creeks. Now, obviously, if we have a 404 permit and we're putting it in a culvert or something like that, then they're appropriate there. But if we're looking to impound sediment, our intent is to not impound sediment in that waterway. So although all BMPs should stay up in our ditches. So sediment traps are paid by the cubic yard. They're intended to be a bigger, more robust ditch check. Okay, that's why there's so much confusion on what do we use and what do we put in, because they look like a rock ditch check. So everybody thinks we'll just throw rock ditch checks out there and it's okay. The sediment trap is intended to be that last line of defense. If it's properly maintained, the life expectancy of these structures will be approximately 2 years. So we want to make sure that they are robust enough to be able to stay, that lifespan. The last 2 ditch checks in any ditch system should be 1 rock ditch check followed by a sediment trap. So always remember, when you're putting your erosion and sediment control plans together, we're looking at sediment traps at every outfall, followed upstream to a rock ditch check, or alternate ditch check if you're inside the clear. Sediment basins. So the design considerations for sediment basins is the location of the sediment basin will be shown on the plans. Basins will be of sufficient size to contain the volume of a 2-year, 24-hour storm event as determined by the National Oceanic and Atmospheric Administration's National Weather Service Atlas 14. Now, I'm going to talk a little bit about the NRCS nomographs that we use and design for hydrology. And I'm not an expert in this, but I did a little bit of research because one of the questions that came back when we talked about what everybody wanted to discuss was why we have to use the NOAA Atlas 14 over the nomographs that we have in UPG. So what I found out was the nomographs were developed by the U.S. Weather Bureau, Technical Paper 14, in 1961, and they were updated through various other studies in 1973 through 1977. There's a white paper out online published by William Merkel, Helen Fox Moody, and Quan Kwong. These are all hydraulic folks from the NRCS. And that white paper basically describes the background and process for the development of NOAA Atlas 14 and the concerns of what drove the need for NOAA Atlas 14. Basically, the concern is that the nomographs don't really represent rainfall of today. They developed so long ago, and there was a concern that though it's been engineering standard to use those nomographs, that they really don't represent the amount of rain intensity and frequency that we see in today's environment. So NOAA Atlas 14 is more of a refined model with more accurate tools than what the NRCS nomographs provide. We really don't have an option to be able to use those nomographs. The federal permit requires, as well as Missouri Clean Water Law and the current permit that we are under today requires that we use NOAA Atlas 14 for consideration of sizing of any BMPs for erosion sediment control. So hope that answers the questions. I encourage you guys to go out and take a look. Search for that white paper if you're really interested in understanding the background of what NOAA Atlas 14 provides us over the nomographs that we have today. It also goes into talk about how it's been a very slow process to getting NOAA Atlas 14 integrated into the engineering design concepts. So I know we're still using the nomographs today, and in no means are we talking about asking people to change the design concepts for ditches and those things. But for sediment basins, sediment traps, any of those BMPs where we have to size, we have to use NOAA Atlas 14 to be compliant with the permit. Sediment basins are required unless they're infeasible. We don't have enough right of way, and then, typically we're not building the types of projects, in recent years where we would be needing additional right of way where we could fit a sediment basin in there. Basically, when we got a project with a large disturbed area, 10 acres or more inside that water or inside the drainage area, you have to consider using a sediment basin. If you can't fit one in there, then you have to supply sufficient BMPs to meet that same protection. So you have to, from the design perspective, we need to make sure that we document that so then we can get that in the SWIP for that project. So that if DNR comes and takes a look at our site and wants to know why we don't have a sediment basin over other BMPs, we can show that we've looked at the numbers in insufficient size, so we went with these other BMPs that equal the same protection. Sediment basins are paid by the cubic yard. Sediment basin has to be large enough to capture material through the construction seasons from the excavation. Okay, you can either dig a hole or you can dam up low-lying areas. Either one are functional. We do have a standard, as you can see on the right-hand side of your screen. NOAA Atlas 14 storm frequency numbers are used for this over the Soil Conservation National Resource Conservation Service, or NRCS hydrographs. Because NOAA Atlas 14 is more precise representation of those, as we said before. So we don't build a lot of these as we move forward with expanding our system. As our program comes up, I think we're going to see more of these. The picture I showed on the previous slide is the one sediment trap our sediment basin, that I know of that we built this year down on the Route 54 project. So it was slightly undersized based on the requirements, but it was let really before we got out with training. But it is functioning appropriately. But understand that as we move forward, we need to make sure we're sizing those based on those localized to 24-hour storm volumes. Inlet protections. The design consideration for inlet protections must have inlet protection where land disturbance operations are planned. We have any inlets in those areas, they need to be protected. Vegetated buffers and or sediment control BMPs such as silt fence or wattle sock should be utilized behind curb sections to prevent sediments from overtopping the curb, or you can leave your fill down below the curb line will function as a BMP as well. Slope drains, we don't see a lot of these, but we really should. From a design perspective, we're not buying any new right-of-way. So, but we're widening our roadway templates, which are making our slopes a lot steeper. So we really should consider utilizing more slope drains. They're used to carry water down the slope to reduce erosion and consist of half-round pipe, metal pipe, or plastic pipe, or a flexible rubber pipe. Slope drains should be considered with high, steep slopes to limit sheet flow, runoff, and causing erosion. Again, another one of those concepts where we see more and more steep slope projects, definitely encouraging the use of slope drains to make sure that we're protecting the outlets of those pipes as we're doing that. Make sure we're not causing more erosion than we're trying to stop with it going over the slope. Erosion control blankets are basically something new that's come in. They've really taken shape over the last 10 or 15 years in the erosion control world. We did update the standards and specs for erosion control back in 2018. Hopefully those, the matrix that came out of that study that we did with the University of Missouri St. Louis is beneficial for design. I know I'm starting to see more and more blanket out on the roadways, but we could use more. Honestly, kind of my unwritten rule is if it slopes flat enough that we can, 3-to-1 or or less, basically we could get away with our normal seed and mulch, and it functions pretty well. But anything greater than a 3-to-1 slope, you really should consider utilizing a blanket. 2-to-1 slopes are really steep, really have a hard time holding seed and straw on those. And so blankets really are beneficial to help hold your soil in place, as well as help keep that seed in place and allow everything to basically begin to grow. So erosion control blankets and turf reinforcement mats should be considered for fill slopes greater than 10 feet high, highly erodible soils, high sheet flows where standard seed and mulch will not withstand the anticipated runoff. Again, that's an engineering judgment, but most of the experience I have seen, again, anything greater than a 3-to-1 slope, we really struggle with holding that seed and mulch on there. Erosion control blankets and turf reinforcement mats or an equivalent erosion control practice is recommended for most slopes, again, greater than 3-to-1. So what drives the need for erosion sediment control plans? The plan is, again, critical to ensure that sensitive site features are protected. The permit basically requires that we provide site maps as part of our SWIP. And so we utilize our erosion sediment control plans as our site maps for compliance with the permit. But having a good plan put together, make sure everything works as it should, and actually helps expedite the construction. It also helps control the prevention of loss of material. I actually had a really interesting conversation with a contractor in Kansas City, where they actually began to see the benefit of additional erosion sediment control measures, because it allowed them to not have to go back and rework slopes, which was basically on their dime, and it was taking more of their time and resources, where if they would have just, the more BMPs they put out there, the less rework they had to do. It was a cheaper alternative to the additional rework. So they are beneficial. And again, the permit requires that SWIP plan put together. So what goes into that erosion sediment control plan sheets? So the permit requires that we show on those erosion sediment control plans our permitted site boundary. And that permitted site is basically any area where MoDOT is going to do work within our right-of-way or temporary easements where our permit is going to be applicable. Okay. Anything that's outside of that limits would be the requirements of the contractor to either permit or, basically they have no choice. If it's 1 acre or greater, they have to get a permit. So inside the permitted boundary is our permit. Anything outside that permitted boundary site is responsibility of the contractor. It's also supposed to show points of discharge to receiving waters, directions of stormwater flows, areas where disturbance and non-disturbance will occur, locations of temporary and permanent structural BMPs, BMPs where water's leaving the job site, or BMPs to cover for the permit obligation, locations of all waters of the state and wetlands, locations where water discharges to another regulated MS4 community. Again, that's water that is directly discharged. If we're running water down a ditch adjacent to another MS4 community, but it's still on our right of way, we're not obligated to show that on our plans. But if we are dumping water directly into a facility that is owned by a regulated municipal separate storm sewer system community, we're obligated to show that and mark that on our plans. So those are all permit requirements. So when we're talking about putting together our erosion sediment control plans, what we've seems like our design has evolved over the last 20 years. When I first started in MoDOT 27 years ago, we used to have white vans of designers and construction engineers driving around looking at projects. And it just seems like the whole field check concept has gone to the wayside with the invention of Google Earth and those types of programs that allow us to be able to see the way the field looks without actually leaving the office. The field checks are critical to actually be able to see what's on the ground. Sometimes Google Earth doesn't have updated photos. You can't see what's up inside a pipe. There's so many different aspects of actually getting out in the field and seeing what's going on and understanding how things are laid out, and potentially maybe where you can see where water runs. It's critical that we still use those field checks. But if it's not possible to do that, another tool that we can use are topo maps. My time I spent in design, which I know was pretty short when it comes to actually being a designer. But now as I look back on it and I think about the projects that I designed, I think looking at topo maps would have made things work a little bit better as I put together my erosion sediment controls. So we're going to talk a little bit about how those work. And as we walk through the project examples, I'll show you the benefits that you can look at a topo map and be able to kind of help you understand maybe where you might want to put your erosion sediment control plans and put your DMPs. So keep that in mind as a tool in your toolbox that you can use is not only Google Earth, but using some topo maps to understand where water's leaving your job site so you know where to put the DMPs. Okay. So let's talk about a few project examples. I got two projects I'm going to talk about, two bridge replacements. I wanted to do a bridge replacement and then one other project, because I know that's basically the types of projects we're doing today. We're taking care of the system. It's not an asphalt overlay job, which is really not a land disturbance project. We're looking at these bridge projects, bridge replacements. So hopefully the concepts that we'll talk about here will give you something to go back and look at your plans and see where you might be able to make some improvements. Okay. So again, before you start your erosion sediment control plans, some concepts to think about. Again, don't wait till the last minute to complete your erosion sediment control plans. Consider all your site geometrics and develop a plan for each phase. Now, the permit always said you needed all phases of construction, and the excuse that I've heard for years is, well, we don't know how the contractor is going to do work. You don't have to know how the contractor is going to work. Then you're going to have your final stabilization phase. Okay? Those generic phases are going to get you through 99% of the projects that we do at MoDOT when it comes to bridge type projects. So think about those as we walk through these projects, and we're looking at what we're seeing with erosion sediment control plans. Again, we have a lot of tools in our toolbox. We have Google Earth, we have TMS, we have ARAN van footage, we have bridge inventory system photos, we have, again, available topo maps online. Outfall BMP should always be should be placed at the ordinary high water mark, okay, or basically the grass line. Ordinary high water, when we're talking about erosion sediment control, is different than what we're talking about ordinary high water for your bridge design. Okay? So when we're talking erosion sediment control, where does that grass line start or stop, however the case may be, and where does the normal bank of the creek start? Okay? So where that grass line is, that is your ordinary high water line. So this is Route F, Dent County. This is actually a box culvert replacement. And the one sheet that you see is the only sheet that you have in this set of plans for erosion and sediment control. Oops, I'm sorry, this is the erosion control plan. This is actually the typical section, plan and profile sheet. So kind of give you an idea of what it looks like. Here is the topo of that same area. So you can see kind of as you look at the contour lines, you can see how the slopes are working toward the creek. You've got a couple of low-lying spots in this area here. You've got water moving this direction. You've got some water moving this direction. You've got some, again, of course, obviously there's probably a ditch line close to the road. You've got some potential for water leaving project sites here. More on this direction over here. Okay, so it's like a small ditch probably right along in here. So you just have to study the erosion control plan. Again, if you're out there and you see where the job, get out on the job site and you're looking at what's on the ground, you can verify that through some topo maps as you're in the office. Okay. This is the erosion control plan for this project. And as you can see, it's pretty minimal. And again, this is typical MoDOT and engineering concept of we'll provide an erosion control plan for the final design. Well, again, what about those other phases? As you can see, I've clipped in the signing cross sections. And the reason I did that was because, we'll step back to this other slide. As you can see over on this side, there are absolutely no ditch checks except for one ditch check right here. Silt fence on the perimeters, except for silt fence on this side. There's silt fence on the other three quads. No ditch checks, silt fence, and ditch checks in the other quads. There are no sediment traps. So things to consider there. Okay. And again, as I flipped through the plans, I saw the signing sheet, and then looking at the signing cross sections. Well, my goodness, sign 13. We've got defined ditches cut right here. We've got potential conveyances where new fill is going to meet the old, and we're going to actually have some ditches here that we need ditch checks in. So we have to stop and think about that as design. Where are we going to have ditches? Where is water going to actually channel and provide ditch checks in those areas? So here is the profile of this route. As you can, it's probably hard for you all to see maybe, but you can utilize your profiles that come out of Geopack to determine what your slopes are, to know how many ditch checks you're going to need in your area. Okay, so you've got 2% grades on each ditch over here. So think about utilizing this tool to determine the amount of ditch checks you need based off what the standard plan provides. Okay, a lot of times, I know from my experience, it was, hey, just throw some ditch checks out there, or call construction. Excuse me, call construction and find out how many they want. Again, we have a lot of tools. We are designers for a reason. Okay, providing the appropriate amount of ditch checks based on what your ditch slopes are, based on your standards. As you can see, here's a ditch on the opposite side. It's an 11% grade. Okay, so oops, let me go back. You can see over here, 11% grade. Very short, but it is pretty steep. So definitely look at those and consider what you've got and what BMP you need. So here's some of the photos. If you're unable to get out in the field, here's photos from the bridge inventory system. And you can see kind of the layout. Some of these are old photos from 2014, but it would at least give you an idea of kind of what the area looks like, what you're working with. And then as you change your design, understanding how you may need to put BMPs out there to protect the waters and stuff. So again, here's this erosion control plan, pretty minimal, right? So when do we install BMPs? Well, this is the only plan we have. So from a contracting perspective, when do we have to install these? Do they go in the beginning? Do they go in the end? I mean, the design is laid out like it is the final design, right? But what about that initial clearing? What about the bridge demo? Again, this is a box culvert. We're going to open up this roadway and we're going to peel it back, be able to get in there and put that box culvert in there. So what about that bridge demo? What about the bridge construction, right? So what I've laid out here is what my evaluation based on what I'm seeing and knowing what operations are going to happen, what I would call an initial clearing and the perimeter control phase might look like. You've got sediment traps in your existing ditches, because again, you're going to come out there, you're going to have to peel back some of that existing roadway. You're going to clear the grass. You need your additional so fences out there. Based on what I'm seeing in the pictures, we ought to have protection on those perimeter control areas where water's leaving our job site. And then make sure we've got those outfalls protected. Okay. So from there, we'll move into the actual demo phase. Again, we're going to peel some of that slope back in a sufficient distance so that it's safe to get in there, get equipment down in there, and get that old bridge out of there, say, and then be able to start putting in the box. So we need the new ditch lines, as you can see, where original rock ditch checks were going, that's got to be the new ditch line, right? So there ought to be sediment traps out in each of those quadrants, as well as maintaining that existing silt fence that we had from the initial EMP phase. And then as we move to actual construction, because we know we're going to put this box culvert in, and we're going to have some steep slopes there, we really ought to look at some type of a protection on those slopes, as because they're going to be open material. Okay, this is one of the big concerns construction always has. How do you protect those slopes when you're putting in a box culvert? So then that way you're keeping that sediment out of the stream, but yet still being able to get in there and actually do some work. Okay, you can't put silt fence around that toe because you can't get it in there. You couldn't install it, and you definitely couldn't maintain it. But you could look at some wattles or socks down that slope, some type of slope interruption BMPs that you could break that sheet flow down, slow it down, and able to capture that sediment as it goes down that slope. So consider that when you're looking at box culvert designs. You can look at completely covering the slope with mulch if you've got sufficient trees in the area that you're clearing. You could use a mulch covering, something like that, to limit the amount of sediment that's going to come down those exposed slopes. Leaving those open really isn't an option anymore. We really need to provide some type of a protection there, and wattles and socks are really a good choice for this type of scenario. So that's basically a box culvert design. Okay, we'll move into looking at a different project. We'll look at Route N, Osage County. And this is a bridge on a pretty steep grade. It really brought a bunch of new concepts and thoughts as you look at what you should be doing with erosion sediment control. As you can see, the grades are pretty steep. As you can see over here, and it's pretty blurry because I had to blow this up, but you've got a 72% grade right here on one side of your ditch. I mean, that's pretty steep. Obviously, there's probably some concern for current erosion going on in that area now. So looking at other BMPs or potential permanent BMPs we might want to look at in those areas if erosion is truly a concern. So you've got 6% grades on the other side, 2% to a 6% grade going off into the right ditch. So we know we've got some substantial grades there, so we know we're going to need quite a few BMPs. So here is the topo area. Obviously, you've got some grades right in here. It's pretty flat out in this area, but it's pretty steep over in this direction. So thinking about considerations, looking at some pictures to understand really what that area looks like is key, so that you can kind of decipher what the maps are showing you. You got a valley right in here, or a valley right in here. And some valleys in here. You're going to have some water leaving direction that way. So consider that as you're looking at your BMP installation on your plans. So here's an aerial view. You can see it drops off pretty quick on this side over here where I have that 72% grade. Obviously, this view does not really show the severe grade from the roadway. So here's some actual photos from the bridge inventory system. As you can see, you've got a pretty good gully going on over here in this area over here. We want to make sure that you get protected, the outfalls there. Pretty good grade coming this way. High steep bank on this side. You're going to want to look at what kind of protections you're going to be able to provide there with those types of steep slopes. So again, here's the single erosion control plan we have for this job. And again, you're seeing quite a few ditch checks on this side. Ditch checks on this side, but not a lot of silt fence. You've only got silt fence on one side of the project over here and over here. A lot of ditch checks on this side. Those all look really good. The perimeter controls really made me a little concerned on this job. Again, when do we install the BMPs? What about that initial clearing phase? What about the bridge demo phase? Be sure to consider constructability as you place the BMPs on your plans too. Consider how the contractor is going to get down to the lower end of the bridge. Okay, so they're going to get down and do their bridge piers are going to have to cut down, especially in a project like this where you've got really high banks. They're going to have to cut down to get to the creek. So considerations of some of those types of scenarios should look at when you're putting your plans together. Okay? Not just protection of ditches, making sure that we've got, if we need some additional silt fence shown in there on one side, you can make the assumption on what side they're going to come in on. And then if that's not right, they'll at least have those BMPs to move to whatever quadrant they're going to actually cut down to move down to the river area. So the initial clearing phase, we ought to have silt fence added on each quadrant. Sediment traps were added here, which is good. They actually had sediment traps in this project here. And that would be sufficient for your initial BMP phase or your initial clearing phase. So then as you move into your bridge demo phase and your bridge construction phase, that's where you want to look at adding some of those additional BMPs. Okay, so in the green, as you can see, I circled a couple of other ditch checks that you probably ought to consider adding, but you're not going to need all of those at one time, because obviously you're going to have to get in there and the contractor's going to have to be able to do some work. And so for considerations of what they really need during that initial bridge construction phase, adding a plan that would lay that out for them would be a lot more beneficial than leaving it up to them to decide what to do. And I think looking at, adding another ditch check over here in this quadrant over here, because you really don't have anything, and are you controlling that soil water volume and velocity? So this plan really wasn't horrible bad, other than the fact that everything was on one sheet. And so consider breaking those up into the different phases. Initial clearing phase, bridge demo or bridge construction phase, and then your final design phase or the final stabilization phase. And that way we have all of those protected, and we're able to actually show, because basically your erosion control has to be a living element. As the geometrics of the project changes, that erosion sediment control has to move with it. So those protections need to be able to move with those changes. So let's take a look at another project, Route H in Jackson County. This is actually an intersection project, very interesting project. Fairly busy looking typical section and plan profile sheet here. As you can see, there's going to be some curb and gutter, some widening and overlay going on in this project. So pretty busy looking plan and profile sheet. So here's the topo of this area. Okay. So Route H moving this way. But anyway, as you can see, you've got field and drainage going this way, drainage going this way. Got some swales going this direction, so we got drainage moving that direction, which is typical for a typical intersection project with some ditches in it. Okay, seems pretty elementary, but when you stop and look at the pictures, if you're not able to get out into the field, Stokewell maps can give you a definite clue on where water's going, why it's moving that direction, and then again, thinking about where you're going to put those VADs. So here's some pictures of the existing intersection from Google Earth. A pretty typical rural intersection. Nothing really too exciting, right? I mean, that'll be a pretty straightforward project. So you got a little bit of a grade right here. Okay. So you got some water moving back this direction, as well as water that's going to break and go the other direction there. So something to consider when you're looking at your erosion control plans. I was really pretty impressed with the set of plans, just because, as you can see, they actually had multiple erosion control plans. Now, do I think that they were perfect? And you'll see there's always room for improvement there, but I think, you know, kudos to this design group. They put together a pretty decent set of plans, considering multiple phases. So we'll look here at the first sheet, phase 1. As you can see, you know, we've got curb and gutter shown going in on this side. We've got a new pipe over here. We've got these entrances being constructed over here. So we've got ditch checks here. But, you know, again, keep in mind what the permit requires. The permit requires all perimeter controls go in prior to any land disturbance activities. Excuse me. So, as you're looking at this phase, we ought to really be showing our sediment traps here and here, which we've got those shown. But if we're really doing work on this side over here, we ought to have our perimeter controls shown in those areas, right? And if we're doing work over here, we ought to have this check shown on this side. If we're not doing this work over here, then we probably ought to look at that from a design perspective and make sure that we're showing in our phases what work is actually being accomplished in this area. Okay? If it is just these entrances, but we ought to have this fence shown here and here. We've got our outlets protected here, which is good. But here we're showing all these checks. When do those go in? Okay. So here is, as you can see, sheet 2 of 4. They've got these neat little notes down here. Initial setup for construction phase 2. Final setup for construction phase 1. Again, here now we've got additional sediment traps shown in each quadrant, which weren't on the previous plan. We've got silt fence that I showed in the earlier photo added here. Okay. And here. And here. And that was for the end of phase 2, or phase 1. Now we're talking about, if you look at the green section, initial setup for phase 2. But we're still not showing these ditch checks over here. So here's sheet 3, initial setup for construction of phase 3, and final for setup of phase 2. There, those ditch checks finally come into play. And then on the final plan sheet, phase 4, or I'm sorry, phase 3, but plan sheet 4, now you can see the whole final package. Okay, complete final design erosion control plans. Okay, this was a really good job. This is something that I think we could look at and say, They did a really good job. I think just their whole concept of understanding when perimeter controls needed to be shown, but really they did a great job. I think we would pass the test from DNR on this one with meeting all the requirements that we have for the permit. So things to consider for success. Consider how the contractor will be able to move around the project and showing where the perimeter controls go. You don't have to be a construction person to have much construction background to think about how is that contractor going to be able to move equipment in and out? How are they going to be able to move within the project, and making sure that we've got those BMPs protected in those areas where we know they have to be. Are sufficient BMPs provided to meet the permit requirement? Are we controlling that stormwater volume and velocity? Are we protecting our outfalls? Are we keeping sediment on our job site? Are we passing water through existing vegetations where possible, promoting infiltration, those types of things? Those are permit requirements that we need to consider for every job. Are perimeter controls shown for each phase of the project? Again, as you can see from the last example, they had them, they just weren't in the same sequence as what you have for a normal set of plans for each phase. I would have preferred to see them all on one page, but they were there, and kudos to that group. And if you were an inspector, would you know when and what BMPs needed to be installed? So as a designer, if you're sitting there and you know, hey, based on how I put my plan sheets together, I know that an inspector is going to be able to follow that understanding of when those BMPs go in and what BMPs are necessary. And does the plan doesn't have to be perfect, okay? That's what I tell construction people all the time. When we put BMPs out there and we do weekly inspections, if we've got failures going on out there, that doesn't mean the project is a failure. It just means it's an opportunity for us to step up and do something different to make sure that we are a success. So your plan doesn't have to always be perfect, but make sure that it gives us a good shot at being a success. Considering all of those requirements, the permit requirements and everything we've talked about today, it's definitely going to set you off on a good path to have a successful project. That's what I have for a presentation today. I appreciate everybody. We're going to open it up to question and answers. So have we got any questions from the panel?
We have an opportunity for us to ask questions at this point. I don't think we have anything but I'm just making sure the Q&A works so far. But I did have one thing I wanted to ask Brian. John, you were talking about the difference in outfall protection and keeping sediment on the job site, or you were talking about those two situations. If we're looking at silt fence versus ditch checks versus sediment traps and sediment basins, is there really a difference in what you would consider outfall protection versus just keeping sediment on the job, or is that all lumped in as the same thing?
Well, there's a concept of, from DNR's perspective, of having sufficient BMPs on your project that you don't have a lot of sediment movement. Okay, so and that all kind of falls in line with being able to control those stormwater volumes and velocities on the project. So having sufficient upstream BMPs compared to solely outfall protections only, that's kind of where there's a big misconception. Just because you have your outfall protections in place, but you don't have any upstream BMPs to be able to control that stormwater volume and velocity, that's really not meeting the permit requirements. So making sure that you have both upstream BMPs and those perimeter controls and outfall protections in place are critical to make sure we're going to be compliant and that we're going to be able to meet all those permit requirements, being able to keep sediment on our job site, being able to control that stormwater volume and velocity so we don't get a lot of that sediment movement going on the project. Does that answer the question, Will?
Yeah, I think so. Thank you.
Any other questions from everybody?
I wanted to mention also that if you all want to ask a verbal question, there's a raise your hand tool within WebEx. So you can go and raise your hand and we can go and unmute you and let you ask that question.
Brian, also we have a question. Will we have access to this PowerPoint?
I can provide the PowerPoint. And it's, I mean, I can place the PowerPoint out on the land disturbance page or the stormwater page if that works for everybody. Or, I mean, obviously this is going to be in mo.u and you'll be able to run through this presentation again if you want, that way as well.
Brian, this is Julie.
Yes, Julie.
We'll also put that on the Design YouTube channel. That's where we're launching some of these videos. And on the Design YouTube channel, you'll be able to just, if you don't want to register in mo.u to get credit, but to go back and reference this PowerPoint, you will be able to find it on that page as well. So we shouldn't need to send it out, Brian. We should have it all taken care of for you.
All right. And always remember, Willie Johnson and I are both available to answer questions, you know, at any time. If you're in the middle of a design and you want to bounce something off of one of us, you know, Willie's a great resource from a construction perspective. You know, he's always happy and willing to answer questions, and I'm also available. You know, feel free to give us a call. Send us a snip of your plan sheet or something, and we can definitely give you our thoughts and opinions. You know, it's definitely getting a fresh set of eyes on things sometimes provides a different perspective. So we're happy to do that, you know, for everybody.
All right, we'll give a little bit more time to a couple more questions. It looks like there's one more in the Q&A maybe.
There's a couple of hands raised too.
So let me throw this question out here from Matt. Are there 3D technologies that can be employed on larger jobs to get accurate representation of the project site?
Somebody, I'm not sure who needs to mute it.
It's Kenny. Kenny needs to mute.
Yeah, let me try this one more time here. The question from Matt says, are there 3D technologies that can be employed on larger jobs to get for accurate representation of the project site?
I'm not really an expert on the whole 3D concept, but I know Steve Atkins and his group. I actually reached out to him before I put this together to see potentially what maybe they're actually putting together on their side from the CAD perspective on erosion sediment control training. He said really there's so much to cover in that training that it's pretty minimal, but I'm sure that there are options out there and available. I would encourage anybody with those types of questions maybe to reach out to CAD group, excuse me, the CAD group, and see if there isn't options available with the new technologies that are available.
Also a question, do you have a link to the MoDOT Design YouTube?
Julie, you want to answer that one? You're muted, I think.
And hopefully everybody learns where those are, but I think it's on the project delivery team side as well, that YouTube channel, but we'll put it out on Design SharePoint or as a follow-up with this meeting or something for you.
Yeah, that'd be a great spot for, you know, on the right-hand navigation side in SharePoint.
We're having a few problems with the unmute, so I know some of you all have your hands up right now. So if you can put your question in the Q&A, we can go ahead and answer that.
Kenny, this is Jessica. Can you hear me? Okay, Shannon Smith, you seem to have your hand raised, so I just tried to unmute you. Can you try to talk, Shannon?
Hello, can you hear me?
Yes.
Okay.
Good question.
It wasn't really a question, more of I'm from the CAD group, and pretty much all of our folks are able to do most everything 3D now. We have several different tools that they are using. One's called Concept Station. If there's an area dealing with a lot of vertical, and having ponds and things like that, we can get really good 3D imagery of that area. And then our geopack and what we're going to ORD, all 3D models and everything like that. So we're able to get the drainage in there a lot better, and we have new drainage tools as well. So I just wanted to throw that out.
Thank you, Shannon. Appreciate that. Glad you.
No problem.
Thank you. Okay, I'm going to mute Shannon again, and then now I see another hand. Matt Burcham. Hi, Matt. Can you speak? Did you have a question?
I actually put it in the question and answer panel there.
Okay.
That was on the 3D question. Yep. Thank you.
Okay. Thank you. Those were the only two hands I see up.
Okay, we have
Yes.
a question that's been sent in.
Stacy Fowler.
Says, I work with the Port Authorities and review their plans. If I have questions while reviewing plans, who should I reach out to?
If you're talking about erosion sediment control, just from that perspective, you can give me a call, or you can, I'm going to throw Willie out there too. You can give either one of us a call. Happy to help in any scenario. I mean, obviously, when we're talking about different authorities, there may be other permits that are applicable, and we need to kind of know what those permit requirements are. Most land disturbance permits follow the same general requirements, and so we can talk about kind of generic concepts on some of those, but I'd be happy to talk with you if you've got questions about those types of projects.
All right. Thank you, Brian, for the great presentation today. If we didn't get to your questions on this topic today,